We're living in an era of extraordinary advancement. Quantum computing, one of the most exciting innovations of the 21st century, is rewriting the rules of what is possible. And with every breakthrough, a new opportunity emerges to make our digital security stronger, more sophisticated, and more future-ready. Today, we'll explore how quantum security is shaping a more trustworthy digital world, opening the door to a new era of innovation and information protection. To understand how quantum security is transforming the world, we must first understand where quantum computing itself comes from. This technology is not just an evolution of classical computing, it's a paradigm shift. For centuries, classical physics gave us tools to understand the world. From Newton's laws to Einstein's theory of relativity, science allows us to precisely describe how objects behave on a large scale: planets, buildings, airplanes. But in the 20th century, scientists discovered that at the microscopic level, the rules are completely different. This is where quantum mechanics emerged. One of the first major ideas came from Max Planck, who discovered that energy doesn't flow continuously, but in a small packet called quanta. Soon after, Niels Bohr used this concept to explain how electrons organize within atoms. But the ideas that truly challenged our intuition were two revolutionary concepts: superposition and quantum entanglement. Superposition means that, at the quantum level, a particle doesn't exist in a single state until it is measured. Imagine tossing a coin in the classical world. It eventually lands on heads or tails. But in the quantum world, the coin can be both heads and tails at once, until we observe it. Then there is the quantum entanglement, one of the most astonishing phenomena in this theory. When two particles are entangled, their states are so deeply linked that measuring one gives you the information about the other, regardless of the distance between them. This doesn't mean one particle affects the other in real time. Rather, they are correlated in a way that has no equivalent in the classical world. In fact, Einstein famously described it as a spooky action at a distance. These ideas won't seem like fascinating through experiments, but today they are the foundation of a technological revolution: quantum computing. The key difference between classical and quantum computers lies in their unit of information: bits versus qubits. A bit can only represent zeros and one. A qubit governed by quantum principles can represent both zeros and one simultaneously through superposition. But qubits go even further, thanks to quantum entanglement. Qubits can work together in unique ways. When qubits are entangled, the state of one is directly linked to the state of the other, no matter distance. This allows quantum computers to not only process information in parallel, but to synchronize calculation at the speeds that traditional systems can reach. Thanks to this capacity, quantum computing is revolutionizing industries like pharmaceuticals, logistics, national security, and artificial intelligence. But perhaps most exciting is the potential to power a new generation of digital security. Quantum computing is not just a future promise. Its development began Over 3 decades ago, in academic labs like MIT, Caltech, Oxford, ETH Zurich, and unexpected places like University of Concepcion, where the theoretical and experimental foundations were laid. Over time, these breakthroughs moved into the private sector. Companies like IBM, Google, and Microsoft began scaling the technology, bringing academic researchers into their teams. Today, institutions like CERN and international consortia are exploring applications in molecular simulations, optimizations, and cybersecurity, while governments worldwide are investing heavily in quantum research and adoption. One of the biggest shifts introduced by this technology is how it affects digital security. The encryption methods we use today are based on mathematical problems that are incredibly difficult for classical computers to solve. Algorithms like RSA, Diffie-Hellman, and elliptical curve cryptography have secured banking, telecommunications, and government systems for decades. But in 1994, mathematician Peter Shor proved that a quantum algorithm could solve these encryption problems in a fraction of the time required by classical computers. While quantum computers today don't yet have the capacity to break the systems, the trajectory of innovation suggests it's only a matter of time. This brings us to a key concept in modern cybersecurity: harvest now and decrypt later. This strategy involves attackers collecting encrypted data today with the intent of decrypting it in the future once quantum computers are powerful enough. The risk is that data considered secure now, financial records, contracts, medical records, government files, could be exposed within the next decade unless organizations adopt quantum-ready security solutions. To ensure information security in the quantum era, companies need to act now. That means adopting proactive strategies and technologies designed to evolve alongside quantum advancements. Digital leaders understand that security is not just a necessity. It's a competitive advantage. Quantum security represents a unique opportunity to strengthen data protection and stay ahead of near-future challenges. But how can organizations adopt quantum technologies without overhauling their entire infrastructure? One of the first steps is implementing quantum random numbers generators, or called QRNGs. QRNGs leverage the laws of quantum mechanics to generate truly random numbers, ensuring cryptographic keys that are impossible to predict or replicate. Unlike classical random number generators, which depend on algorithms and can be vulnerable to attack, QRNGs offer a level of security that evolves with quantum computing. Quantum computing is not just a technological advancement. It's a transformation in how we process and protect information. Quantum security is not a future concept. It's a strategy we must adopt today. Companies, governments, and industries are already taking steps to safeguard their most critical data in the quantum era. Those who begin their transition now won't just be protecting their information. They'll be leading the next generation of digital security, helping ensure humanity's digital freedom.